Hi, this is Unit 1 practice problems. So we're going to go over indeterminate limit, IVT, and limit with infinity. So let's start. So for this one, we need to first determine that it's indeterminate. Ooh, tongue twister. And so to do that, we would have to plug in the number that x is approaching and what we want to get y to. And so in this case, it's 0. If we were to plug in 0, we would get 1 plus 0 minus 1 over 0. That's just 1 minus 1, 0 over 0. And so that is indeterminate. Cool, but now what do we do from here? So next thing that we want to do is kind of simplify this and get it to a point that we can solve without it being undefined, or in this case, indeterminate. So limit of x approaching 0 of 1 plus x minus 1 over x. So what is one thing that we can do? So we can obviously multiply by a different form of 1, aka the conjugate of this equation, this equation up top. So if we do that, it's basically like doing the difference of squares that we learned that in like algebra 1. So if we do that, we would basically have to just square this with this and square these two with the negative. And so next step, limit x approaches 0. So the top part would just be 1 plus x minus 1 over x times the square root 1 plus x plus 1. Cool. And so now we can just simplify both parts. Or actually, no. We only need to simplify the first part. So we get x square root 1 plus x plus 1. And so the reason we don't want to simplify the bottom part is because now we can notice that we can just cross out these two top parts to get limit x approaches 0, 1 over square root 1 plus x plus 1. And so what's our last step? Our last step is plugging in the 0. And in this case, we are not going to get indeterminate because there's no x on the top and x on the bottom. So we would get 1 over 1 plus 0 is 1. 1 plus 1 is 1. 1 half. Okay. Next one is an IVT question, so it asks about continuity. The function f is defined by f of x equals square root 25 minus x squared. And for this domain right here, let g be the function defined by g of x, insert piecewise right there. Is g continuous at x equals -3? Use the definition of continuity to explain. So what we first want to do is make sure that the one-sided limits add up. And then the second thing we want to do is prove that it's continuous by using IVT. So the first thing that we want to do is make sure the one-sided limits are the same. So in this case, we are looking for x equals -3. So the limit of x approaching -3 on the negative side of g of x equals the limit of x approaching -3 to the left side of f of x is basically saying limit of x approaches -3 to the left side of 25 minus x squared. So what does this equal? We basically just need to plug in the x, which is -3. So 25 minus 9 equals 16. Square root of 16 is 4. So this is the left side that we've proved. Now we got to prove the right side. And see here, for this equation, it doesn't go to the right side. So it's only talking about the left. And so this one is talking about the right. So limit x approaches -3 to the positive side g of x equals limit x approaches negative 3 to the positive side, x plus 7 equals negative 3 plus 7, that's 4. So we proved the right side and the left side. So we're done with that. And now we want to prove that it's continuous. So for it to be continuous, these 2 points have to be defined. Obviously, we know that because, we plugged it in and it wasn't undefined or does not exist or anything. But for the sake of calculus, we have to define that and give an explanation. So we can say, therefore, limit of x approaches negative 3 of g of x equals 4. So basically proving this. And now we want to see if g of negative 3 is actually a function. So g of negative 3 would have to be equal to f of negative 3 as per the piecewise, and then that would equal 4 because we literally did the work right there. So the limit of x approaching negative 3 of g of x equals g of negative 3. So we want to prove that they're both equal because 4 equals 4 equals 4 equals 4. Therefore, lots of 4s. G is continuous at x equals negative 3. Actually, this isn't even an IVT question. What am I saying? This is a question on continuity. Oh. Okay. Next question is limit with infinity. So for finding limits of infinity, we need to see if there is a horizontal asymptote or not. And so it basically, if there was a horizontal asymptote, let's say that was the horizontal asymptote and the graph looked like that, and we wanted the limit to infinity, so basically over here on this side, then whatever this value of the horizontal asymptote was would be the limit because it's forever approaching this. Never crosses it, but it'll forever approach it. So knowing that, if you remember from either pre-cal or algebra 2, the horizontal asymptote depends on the power of the leading term. So in this case, they're both the same. So that would mean that the leading coefficient divided by the other leading coefficient would equal the horizontal asymptote. So in this case, since they both have the same power, we can do horizontal asymptote equals 2 over negative 5. And so to write out all fancy, we can do limit x approaches infinity, 2x to the power 4 minus x squared plus 8x over negative 5 x to the power 4 plus 7 equals 2 over negative 5. And that's about it. Thank you for watching.